So in the beginning of chapter 10, we really focused on all the different types of graphs and charts that you could use to display data and when we use each one and how they can be useful. In 10.4, we really want to focus on how they can be misleading now so that you understand whoever creates the charts and graphs, they might have a motive behind it. We want to make sure you are an investigator of what you see and that you investigate the chart and all parts of it to make sure that it's not misleading or biased in some way. So our target for today is going to be that we can recognize misleading charts and graphs, and we're going to focus on three parts of that. What I mean by that is, okay, the first thing you're going to identify is why is the graph misleading? I want you to think about what part of the graph is wrong. It's something you're not allowed to do, it's a mistake, or maybe you're allowed to do it but it's the part that's wrong, or causing us to interpret the graph in a specific way. Then for part B, I want you to think about, well, what might people believe because of the misleading graph? So what is something that you believe from reading the misleading graph? This should be something that is not actually true. Be specific and try comparing sizes, etc., and we'll go through some of that as well. And then see who might want to use this graph. So who would have the motive for you to interpret the graph the way that you did that was wrong, the misinterpreting of it? Who would have the motive behind that? So I actually want you to try the first three on your own. There's three examples, one with a bar graph, one with a line graph, and one with a pie chart. I want you to try all three. You can pause the video, try all three, answer A, B, and C about them, and then we'll go through and discuss them before going on to misleading statistics. So pause the video now, try examples 1, 2, and 3, and then press play. Okay, so now that you've completed examples 1, 2, and 3, let's go over them. We'll compare answers, and I want to point out a few specific criteria that I want to make sure you have. So in this first graph, you probably noticed that the graph is a little misleading because of the break on the y-axis. The break, a break on a graph is allowed in math. That's not illegal. That's not something you can't do. However, the break on the y-axis causes the differences between the bars to be exaggerated. Make sure you have something down about that. The break exaggerates the difference in sizes of the bars. It's not something that's wrong, it just makes the difference appear like a lot. So make sure you have something about the break causing the exaggeration. For B then, what might people believe from this graph? Remember, this is something that you have to say, this is something that has to be false, something that's not really true, okay? So you could say that I might believe from this graph that brand B has a higher customer satisfaction than brand A, but that is something that is true from this graph, right? That's true even if the graph wasn't misleading. Brand B does have a higher customer satisfaction rate, so that wouldn't be a good answer for B. A good answer for B would be something like someone might believe that brand B has twice the customer satisfaction as brand A. Make sure that you compare the bar sizes in an example like this. I really like the twice. That really is specific in the comparing, and that's the part that is misleading. Brand B looks like its customer satisfaction is twice as much as brand A, when really they're 86 and 79%, they're not that far apart. Yes, brand B does still have a higher customer satisfaction, so that's not something that's false. Make sure you compare the sizes there if you didn't add that in. And then who might want to use this? Obviously the people who work for brand B, maybe the marketers or maybe their owners, something like that. For example 2 then, you probably noticed that the graph is misleading because the scale on the y-axis is not constant. Here we're counting by tens, every other line. Now we counted by 10 from here. So this is 10, but then all the rest of them are 10 in half the space. The problem is the scale on the y-axis is not constant. Now, for what might people believe from this graph, remember, you have to say something that is really false, okay, but because of the problem in the graph, because of the scale on the y-axis not being constant, it looks true. So it appears the rainfall decreased more from 97 to 98 than any other year. But really, this decrease is about the same from 98 to 99 and about the same from 2000 to 2010. So when you look at the change and count it, this looks like it's maybe at 41 and it goes up to about 51. So it looks like it's about a change of 10 inches. This is also a change of 10 inches. This is also a change of around 10 inches. So something that's false, because the graph is misleading, is I would say it looks like it decreased more from 97 to 98 than any other year, when really that's not true. Who might want to use this? You have some flexibility on this part. I would say, you know, we see a decrease in rainfall. That sounds like a good thing if you're going to go on like vacation. So maybe a city that's trying to attract more tourists to visit them. You could also say maybe like environmentalists might use this to say that we have a problem with the environment because of pollution or whatever, and it's a bad thing that the rainfall is decreasing. So you have some variability there on C. This isn't on your notes, but I added it in, so think about this before you move on. How would this graph look different if the y-axis scaled from 0 to 100 without stretching it any longer? So if within the same space we had a graph that was 0 to 100 up here, how would the graph look different? Well, you would still have the change, but now your graph would be, you know, a little bit closer together. It might look a little more even. The graph would probably look something like that. And in that case, somebody would use that if they were trying to show maybe that the rainfall hasn't changed that much over time. So you really have to think about how you scale your axis and how it can affect your graph. Overscaling could be just as misleading as miscounting or underscaling. And the last example with this type, we have the county budget for 2005 and a pie chart. Why is this misleading? You probably saw this one right away. The percents do not add up to 100% for this pie chart. That is the problem. So what might you believe from this graph? Well, from looking just at the slices, I might believe that road maintenance is more than half of the county budget, right? I can see that it's only 25%, but just looking right here, I might think road maintenance is more than half of the budget. Who might want to use this then? I said maybe the parks and recreations or garbage collection might want to, might want to use this when asking for more money from the budget, if they want to get a pay increase or maybe they just want to have a new park built or something like that. You might also have something on there as maybe somebody who's trying to hide where they spent the money. If you are only seeing 60% of the county budget, where did the rest of it go? So graphs can be very misleading. Make sure you really investigate what you see. Look at all parts of it. You want to make sure you're not being misled and are unaware of it. Statistics can be misleading because of the way the data is collected or the way that the results are reported. So you want to make sure you know that as well. A random sample is a good way to collect unbiased data. All members of the group being surveyed have an equal chance of being selected. That's what a simple random sample would be. So here's two statistics. I want you to think about how the results are reported and how the data is collected and in what causes these two to be misleading. Pause, try example 4 and 5, and then press play to go over them with me. Okay, so you've read over 4 and 5. Let's see what you think is misleading. In this first one, we have 5 households reporting the number of pets they have. Why would the average household has 3 pets be a misleading statement? Average is always mean, and if you find the mean to these numbers, 3, 4, 13, 14, 15, 15 divided by 5 is 3. The mean is 3, so that's not wrong. However, I think for this data set, 9 is kind of an outlier, and this makes the mean more than most of the data values. It kind of skews the mean a little bit. In this case, the median might be better to represent the data. 4 out of the 5 households have less than 3 pets, so I don't think 3 is a good measure. If you took the median of this, though, that would be 2, and 2 is very close to 4 of the 5 data values. So you want to think about whether the mean or the median is being used and which one would be better for the situation when reading statistics. In example 5, you have 5 people asked if they like to snow ski, and the statement is 80% of people like to snow ski. Well, 80% of what people? 80% of all people in the world? You only asked 5. So there's one problem I see. I think the sample space is too small for you to say a percentage about just people. The other thing I question is, where was the question asked and how were the people chosen? Do we know if they asked everybody around them or every 5th person or a random selection? Or maybe they asked their friends. Maybe they were at Seven Springs when they asked this question. Or were they in California when they asked this question? So you have to think about how the data is selected as well, or and collected as well, for you to know if it's going to be biased or not. All right, so a little extension. Turn the page. The next packet, the paper in your packet, is on sampling and bias. You have 3 different types of random samples and 2 different types of bias samples. You also have to identify what the population is and what the sample is. So population is going to be the larger group of who you'd be talking about in general, whereas the sample is the smaller group that's actually chosen. And then there's all these different types. I want you to read over this page, and you're going to try the problems on the bottom. So read over this first, and we'll look at this example together. On an assembly line, every 100th hinge is removed and inspected. Identify the sample and suggest a population from which the sample was selected, then classify the sample. So the sample is every 100th hinge is the one that's inspected. So the sample, the ones that are actually being chosen, are every 100th item. The population then, well, what had a possibility of being selected? The population here would be every hinge on the assembly line. The selected ones are the sample, that's the 100th hinge. Then the last thing for you to do is identify the sample type or classification. Since it was systematically chosen, it was sticking to a rule of every 100th item. This would be a systematic random sample. That is a good type, that's unbiased. So I want you to read over all the types, read it carefully, complete 1 through 5, then press play to check your answers. Go ahead and pause and do that now. Okay, so now that you've completed the 5 practice problems, check your answers with me. Make sure you identified all 3 parts though first. Make sure you did identify the population and the sample within each situation, and then classifying the sample. So let's go over the answers here. Read over the details in these solutions and make sure you do have all parts, guys. It's very important for you to understand what the population and the sample are. The population can only be made up of every student who had a chance of being in the sample. So for 1, 2, and 4, I would say that it would be all students at that school had a chance. For number 3, since it's a math teacher selects every 5th person in their class, I said that the population would be all the students in that teacher's class. The sample then is just every 5th person for number 3. The first one was a voluntary response, which is biased. Make sure you know that voluntary means biased. The second one is a stratified response, so it's random, that's good. The third one is a systematic random, and the 4th one is a convenience biased. Convenience is also biased. And then number 5, the option A, simple random, is correct. Make sure again that you check over that you identified the populations and the samples correctly. Make any corrections that you need to.